Hi, I'm Ned and I make games. This video is from my live stream over on twitch.tv/NedMakesGames, where I'm live Monday, Wednesday, and Friday at 9 p.m. US Eastern Time. I'd love to see you there. Alright, let's get started. Alright, hey everybody, how are you doing today? Sorry I'm a little bit late, I had some stuff pop up right at the last second, of course. Seems to be how it always goes, but I'll be here now. Maybe we'll make up the time by streaming a little later, but anyway, so a couple things before I get started. Actually, I got the mail yesterday that I've been accepted into the Twitch affiliate program, so thanks everybody for watching me so far. It's pretty exciting. I need to make now I need to make some emotes. So if you have any cool ideas, let me know. I'm thinking I'll have something like, I don't know, squashing a bug emote, maybe some kind of shader, error, magenta, something like that. But yeah, if you have any good ideas, please let me know. Another exciting thing is I finally did figure out how to do that grass projection from the camera that I was trying to figure out a couple of days ago. So you might remember before, well, for one, sometimes the grass buffer would not be cleared correctly, so we'd get like a bunch of polygons where they weren't supposed to be. And then also this block would not prevent the grass on the bottom from, I guess, being in the shadow, so grass would grow underneath the block. I was able to fix both those problems, so I'm pretty excited about that. I'll go over really quick how I did that. Oh, also, don't worry about this. The grass kind of spinning around on the top block. That's just because of the way I'm getting random values right now. It's based on the world position. So whenever this moves, even like slightly, yeah, the rotation changes a lot, but we'll have to fix that somehow. All right. I forgot to load this beforehand, but okay, so let's see. Oh, 1 second. All right, now it's all loaded. Okay, so I can't remember where I got to last stream, basically, but I made a renderer feature that sets up all of the, I guess, buffers for the grass. So what we do is we create a buffer that basically will hold all the places that we want grass to spawn. And as well, we have to set up an index buffer so Unity will be able to create polygons from this data later on. And then we also have an indirect arguments buffer, which we use to count the number of polygons to draw, basically. I'll come back to this. And here I'm creating the index buffer. So it just, for every grass, I guess right now grass is just a quad. So it's two rectangles, or not two rectangles, two triangles. And then we just set that up here. And then we create the pass object and give it some initialization data. And then on add render passes, we get rid of, or we ignore any camera that's used in the scene view, just because otherwise there's some weird stuff. I guess maybe I can show you. And then we enqueue the pass. Well, yeah, let's see what happens when I take this away. Actually, I haven't tested it in a while. Maybe it will work now. I kind of doubt it, but yeah, it still doesn't show really. Although, oh, that's kind of interesting. That's a side effect from something else. But, okay, so yeah, we enqueue the pass. And then the pass, basically at the beginning of when it runs, we have to set several values on the graphics pipeline. First, we reset the sprout buffer, so the count's at 0, and then we also set, this is to reset the triangle buffer, or the triangle count. And then, again, I'll come back to this in a second. That's, this was like problem number 1. And then we use it, so the main thing is we want to use a camera to see, oh. I'm kind of surprised it's clear here. I thought, oh yeah, see, I thought you'd be able to see these grass objects, but so we have a camera that would just try to view these grass terrain objects, and it wants to spawn grass on top of them. And the cool thing about that is you can, let's see if I see both views at the same time. Okay, so yeah, it doesn't like it. It's one weird thing about this system. As you can see, it's not liking having two cameras running. Might be, maybe I'll try to fix that, but anyway, so you can see this block is moving back and forth, and so the camera is spawning grass on top of it. And the way I do that is I have this lit pass in the shader, which basically every time the fragment runs, which I want it to run for every pixel in a render texture, it will read data about the mesh that it raycasts to, and then sprout grass on top of that by adding it to the grass buffer. And then we have another shader that just reads that grass buffer data and changes it into the quad, and then does some lighting and things like that. So that's basically how it worked. But the first problem we had was sometimes, let me see if I can recreate it. So it'd be kind of like this. You get like this random error data. And it happened because I was only setting the random right targets once. Like right here, you can call graphics. Oh, that was right. Set random right target, then you give it an index and set the buffer. But you have to do that every frame, because every time you change the render target on the camera, Unity wipes those read-write targets, and you have to mark a buffer as read write enabled for a fragment shader to be able to write to it. So the indices that we put in here, like this 2 and the 1, have to correspond to these registers that basically a register is kind of like a global buffer that all shaders can access. So yeah, in C# you have to mark them as being a random right target, and then you also have to reference it in the shader. And then I also reference it here, which I wonder if I still have to, because I actually read this from the vertex stage. Okay, yeah, well, I guess I'll press play to see. Yeah, so I still have to mark that. I need to do a little bit more research, because I'm kind of curious why I have to set the register for this, even though like in the future I register the buffers under a global buffer call to the reference name, but that doesn't seem to work in this case. I don't really know why that happens, but I'll have to do a little bit more research about that. So anyway, when I set all this up and I set these as random right targets in every frame, then that got rid of the junk data appearing. The other issue, which I can easily show, is basically the grass targets weren't occluding, so you get grass on top and underneath. So I think last stream, I guess, I don't know if I was tired or just misunderstanding, but I said that I was surprised it wasn't doing depth occlusion, but the reason is because Unity calculates the depth and color like at the same time, so the fragment function has to run once for it to get the depth. So how you can fix that is running a separate depth only prepass, which I've done here. I have this depth only prepass, and this only renders depth into the depth buffer and doesn't actually call our fragment function. And then you run the color pass over that, but tell it not to write to the depth buffer, and then it will use the depth buffer that already existed. And but even when you do that, the fragment function will still always run unless you tag it with this early depth stencil tag, and this tells the renderer that we don't want this fragment function to run at all if it fails a depth test. So you have to do both of those things to get it to work how I needed it. So how I got a depth prepass was I just have another render objects renderer feature. I set it up this way. And then afterwards I did my grass sprout feature, which handles all the buffers. So anyway, I've spent quite a bit of time since the last stream trying to get this all to work. And I think I'm pretty happy with it. It still seems to run pretty well. I'm still getting about 600-700 FPS even with OBS running, so I'd say that's a success. Also, I'm sorry about, it seems like my internet's not being super nice tonight, but hopefully it will clear up. Anyway, okay, so now what we want to do is try to get this looking better. I guess I can just, let's set up some actual grass textures instead of using this purple and blue. So I don't have one. Let's pull some from another project. This way it'll look nice. I think I have it set up. Yeah. No, it's not it. Okay, and then I'll just open this in Explorer so I can copy it. Okay, so yeah, this was some grass I made earlier. It's gonna, well, we'll use it for now. It might not be the best for this purpose. So I'm gonna set alpha to transparency and also, no, I want preserve coverage. All right, and I think I can just place it in our grass. Blades material. Okay, and then I set the threshold to 1/2. Okay, I mean, that'll do. Doesn't look too bad. Yeah, unfortunately you can't see this in the scene view, which I think is a bit of a shame, but I don't know. Well, I guess, let me see. I forget what I did for the other feature. So I have a grass sprout feature, which sets up all the buffers, and then I have this grass draw feature, which calls draw procedural indirect. Okay, it also ignores the scene camera, so I wonder if I got rid of both of these, if you could see grass in the scene editor, or the scene view. I'm not sure, but okay. If I press play, does it look right? It's kind of weird. And then if they're both visible, I think... Oh, actually, if they're both visible, it's a little... It doesn't mess up the game view anymore, which is nice. So, I wonder if I just had this one ignore the scene camera. And unfortunately, I don't think there's a better way to do this. Okay, no, that doesn't help. Well, I don't know what is better. I'll have to look into it a little more. Because, yeah, unfortunately, there's no way... So, like, for a real camera in Unity, you can set up the soil camera to, like, run through the sprout renderer, and then the main camera run through the default renderer so that they don't... so one feature only runs on one camera, but you can't control what features run on the scene camera, which is kind of a shame. So... I mean, I guess the most important thing is it works in the game view. But... Okay, so... I guess the next thing is I'd like the grass to be a bit more stable. Like, because when this block moves, the grass moves back and forth a whole lot. Which I'm, actually, I'm slightly surprised that happens, because I would think the grass would only move based on the camera. Like, if I move the camera back and forth, everything moves because the, because all this random stuff is based on the world position. So when I adjust the camera, it's going to slightly adjust the world position of each of these grass blades. But when I move the anchors, that happens as well. I guess the reason why... let's see. Here, that's what I'm looking for. Is because, yeah, we get world position based on interpolating from the fragment function. Or from the vertex function, so it starts by the position of the vertex. So I guess we could, like, snap this to the cells in the world. Let's try that. Yeah, I'm sorry, it seems like my internet is still not running too well. I do apologize for that. So what I'd want to do is basically take the input. I wonder if I could do this on the vertex stage. Probably best not to. So we need to take the world position and then snap it to this pixel grid, so that way small changes don't perturb the pixels quite so much, or perturb the randomness quite so much. But yeah, this is, we'll get to that later, I think. So float 2, R3, grid. position world space equals input position world space. So I need to snap it to the grid. So I think I have to divide first and then floor. And then multiply by the pixel size again. Probably pixel's not the best term for this. Maybe I should change that before I go any further. I guess this grid size is fine. Or cell is even better, because grid kind of, to me, denotes more like the count, or like the number of cells. Okay, and then we can just pass this through. Let's see how that looks. Oh, well, it's not going to work at all right now because the grid size is 0. So, this actually wouldn't know about that. It's, this texture creator is what figures out the size of, because basically the cell size is the size of 1 pixel in this texture. Okay, so I would take this and then, okay, so this is the world size is the size of like the camera's viewport and world space. So I guess I would take this texture size and then divide it by the world size, and that would give me the pixels per world unit, but I need world units per pixel, so the other way around. Cell size 2D is texture size divided by our world size divided by texture size. Might not work. I think I need to texture size and then times 1 divided by, or no, I keep on doing it backwards. It's world size divided by texture. So I have to do new float 2 world size, and this just creates a float 2 from this. And really the texture size could just be, I mean, it's all the same. So maybe I don't have to do 2D first. Divided by new float 3 texture size dot x. Okay. In fact, I could just do this even easier. And then I just need to upload this as a global shader variable. Set global float grass cell size set global vector actually. And then yeah, this has to be a float 4, so I can just pass cell size and then put 0 in the last component. Okay. Oh yeah, that's much better. So now when it moves back and forth, the grass snaps to the pixel grid, and you don't see that wild rotation. Yeah, it even works here. No, it doesn't work when I move the camera. Yeah, that does. Okay. I wasn't sure. Okay, so now I need to make sure when the camera moves, I guess it doesn't really matter. I was going to say the camera should also snap to this grid, but there is some bits. You could kind of see it flashes back and forth when that when the anchor moves. Let me turn off the thing that's moving it back and forth. Yeah, so I don't like that snapping back and forth. So I guess I do need to snap the camera's position to the grass grid. So what would be the best way to do that? Well, I'm going to need a system that will control the camera movement, because like this camera is going to have to kind of move around based on wherever the player is looking. So I guess we might as well just create that now. All right, so grass, soil, camera, positioner. And this can be mono behavior. All right, and I should probably make a better way to handle this, but for now I'm just going to have a public function float 3 grass cell size, and then we'll set this from the texture creator. The other way I could do it is this class would grab the texture creator and then read the cell size from it. But I think this way they're decoupled a little more. So yeah, so get and set. So here we'll find objects of type, grass, soil, camera positioner, and then we can set the grass cell size. Okay, so now shaders have it, and then this class has it. And basically what I want to do is when we set the camera, it should snap. Okay, so I guess this needs a reference to the soil camera. I could just make this all one class, like the soil camera manager. I don't really know if they need to be separate. Because then you'll have to worry about setting them both up. Kind of like that idea, actually. I always go back and forth whether it's better to have a bunch of small components or one big one when they all like depend on each other. Because having one big one makes it so you're less likely to forget to set one up. But there's pros and cons to each, so I'm not sure. I guess I'll leave this class here in case I change my mind. All right. Okay, so yeah, on awake, we'll want to set up the render texture. I guess we can copy this whole thing because, yeah, we'll still want this blades per unit area. Okay, and now we can just save the cell size. Yeah, I don't have to. Oops. I do need to set it in the shader, but I don't have to set it there. I'm really sorry about my internet tonight. It's been so good until tonight. I don't know. I mean, I could go reset the router, but I don't want to have to restart the stream. I don't know. Okay. Yeah, I guess I'll go start my router, so I'll be back in just a couple minutes. Alright. Hopefully that helps with my internet. I'm really sorry. The universe doesn't want me to stream tonight, it seems like, but I'm gonna prove it wrong. Anyway. Yeah, I hope that... I mean, if my bitrate's bad, I'm gonna just... Nothing I can do about it, so I'm just gonna stream as well as I can. I do apologize, but we'll see. Seems to be slightly better than it was before. Anyway, let's keep going with this. So yeah, we need to snap the camera to the cell size. So I think I'll have the soil manager. I think just to make it obvious what it does, it should just go on its own object, and then we'll have a reference to the soil camera, and then I don't know, something for the transform soil camera anchor, and then we'll also want to have like a follow anchor. So it will try to set the soil camera anchor to the same position as the follow anchor, except snapped to the grid. Okay, so where do I... Okay. That takes care of that. And then an update, we'll get the follow position, which is the follow anchor dot transform, and then we just need to snap it. Snapped position equals, so we've got a, it's just the same as before, so we call math floor. Oh yeah, this should just be position, not transform. And the follow position divided by the cell size and then multiplied by the cell size. And then we could just set the soil camera anchor to this new snapped position. Okay. Now we got to set all this up here. Let's do, this will be the soil anchor. And this is just so that you can have like a depth to the soil camera and I don't have to worry about setting the correct depth all the time on the manager. Let's rename this to big soil, and then I'll have a soil block. I should have done that earlier. And this grass render we can get rid of. That was an old system. So let's create the follow anchor. And this can be placed. It could be the player game object or whatever. And then we'll have one more for the grass manager. And we can place that the soil camera manager. Okay. Also, yeah, I need to remove this texture creator. Oops. So that was 2 blades per unit area, which is kind of low for now, but we'll leave it. And then we've got the anchor and the follow anchor. Okay, so let's see how this works. No errors so far, so that's good. Now if I move this back and forth. Okay, yeah, I don't get any more of those weird things where the grass would like kind of flicker underneath or at the edge of the soil block. Oh, I think I moved it too much. But yeah, so when this moves, like right now it's at, I don't know, 1.81, and then the soil anchor is snapped to 125. So I can lock that and then bring up another inspector. I don't really want to anchor it anywhere. And then yeah, we can move it and you can see apparently the cell size is 0.625, so you can see it's always a multiple of that. Yeah, right now it uses the floor. Maybe we should round instead of doing floor. I don't know. It doesn't really matter, but we just need to make sure we do it the same way in the shader and also here. So probably rounding is better because it's, I don't know, more centered. Oh, except that doesn't work very well. Okay, back to floor it is. I guess that makes sense because now I'm a little worried that this isn't going to be correct for all shapes. But I guess, yeah, we'll fix that problem when it comes to it. And also works while moving Y, but I guess that doesn't really change anything with the grass. And then the Z, also good. Oops. Okay, and I can just, let's create another soil block. Okay, yeah, I just wanted to make sure. And then we can change the Y position. Okay, so maybe it shouldn't snap to the Y because, yeah, now it's not going to always fall directly on top of the block. It's see how it's snapping. You can't really see it, but like if we had also a solid, yeah, maybe I should probably be testing that. But if I have like a solid block underneath here, it might not match up. Okay, let's see. Probably, I would say the soil block should be a child of the actual visible block. So let's copy. And then I don't really need a collider on it. And then we'll copy this component. Oops. copy this component to the visible block. And then I'll make the soil block a child underneath the visible block. Okay, so I'm just going to make sure this works. Okay, well, it's getting shadows, so that's fine, I guess. I'm not worried really too much about lighting yet. We'll fix that later. Although, yeah, it doesn't look the best right now. Okay, so it's a little weird. I think it's just because the grass, well, obviously the grass doesn't move with a moving block, but I'm not worried too much about that because like in an actual game, you're not really going to have, well, I mean, if you do have terrain like this, you'll have to have a different, solution, I guess, but I guess you just tie the grass on top of the block. But this system I'm writing is for like static terrain, so I don't mind so much that it's, doesn't move with the block. And then also it seems to go off the side, and that, I don't think that's a huge issue either, because there's other ways we can fix that, which I'll get to pretty soon. Although, I think it would look better if we could do rounding, but it doesn't look as good. Because then I feel like the grass would snap to a better position. What if we did, I feel like this is identical, but maybe it'll just work better if we do something and then like add 0.5. Yeah, I thought it was probably identical. Okay, but does it, like if I tell this thing to stop moving back and forth? Okay, but does it happen when I move the camera? No, it doesn't. So, okay, maybe we should just go all in with not really supporting moving terrain. Because it looks fine when you just move the camera, and it makes the grass not hang off the side as often, because it'll be in the center of every cell instead of on the edge. So I think that's okay. We'll do this. But one thing I do need to fix that issue with the Y coordinate, because the grass kind of like gets smushed inside, and that's not good. And yeah, the Y position on the camera doesn't really make any difference either, so. Okay, so I could just change this to round. Because I think those are equivalent math formulas. All right. So, okay, so we need to make it so that this doesn't change the Y component, and all I have to do is just set cell size.y to 1. And we don't have to handle it any other special way. Oh, well, actually, no, that won't work because we still use floor. So, like, yeah, if I move this up, it's still not gonna So yeah, unfortunately I do have to change it a little bit. Okay, so I don't think there's really an elegant way to do this. Let's simplify it. I mean, is there really any reason why we'll ever use, like, we'll ever have X and Z be different? I don't think so. So let's just change cell size to be a float. And then this we could just change to set global float. Because we're already going to have to handle the Y component in a special way. And then snapped position.y equals follow position.y. Because we just won't snap the Y component. And in the shader, I think I'll just, the easiest way is just to do the same thing. So grid position world space.y is input position world space.y. And yeah, change this to just a float. Okay, so now the grass should freely move up and down. Although, yeah, that makes it kind of, that makes it start rotating wildly. What's with this thing, right? Or this, like, invisible line right there. We'll fix that in a second. So what we need to do to fix that is basically just make the position not depend on the Y coordinate. So, let's just change. Yeah, so we can still use these functions, but I need to change this. An easier way is maybe I could just use remap, but okay, so we'll just do rand 3D to 1D, and then I'll just pass in position XZ offset. Okay, it's gonna say it conflicts with this one. I don't think I should have these functions anyway. They're too specific. I guess we can do the same thing here, except we just won't transform it to be from -1 to 1. Okay, so now the random number is not dependent on the Z component, so that does work. Although, what's the deal with that missing stripe? Okay, I'll stop this. And then if I turn off the renderer, The grass isn't like... Why is that happening? That's so strange. It's like it only happens for some reason when the grass is like above Y, but I don't think that the Y component affects it at all. Because the Y component of the position only is set here. Okay, let's see. And I don't know why it only happens for this one row. If I move this soil up, that's so strange. I don't know if I'll mess with it yet because I'm hoping that as we go it might just fix itself. Because it might be something with having incomplete shaders. But yeah, that's kind of weird. If I move... Okay, so it kind of like... I wonder if it's an issue. It seems to happen at specific points, so I think it has something to do with the grid snapping. Maybe it's a floating point error. But it's kind of weird. But yeah, we should check if it works. I'm trying to rotate it this way. Yeah, it does work, but it's a little weird right now. I don't really mind so much if it looks weird on pointed on like this kind of terrain, because like in your actual game you won't really want grass to grow on these parts, so you'll turn it off. But I'm glad that it at least tries to place grass on it and it doesn't look too bad. Anyway, so what could be this system? I don't really know why it only happens when Y is like not 0. But I'm not going to worry about it too much. Anyway, I was trying to make this soil visible before I got sidetracked. Okay, and then I'll just give it default material. Okay, let's just make a default material. Material, soil. I'll just make it vaguely brown. That's way too saturated. And then in order to get it to show up, I just need to set it to the default layer. Okay. It doesn't look good at all with the environmental lighting, but Okay, so let's try to make the soil camera have a wider size. Okay, so now the buffer is too small for the amount of camera that or for the amount of soil that the camera is trying to spawn. So in order to do that, in order to fix that, I just need to go to this sprout render and increase the max sprouts. I'll do 5,000. Okay, there we go. So now we have 5,000 grass sprouts. We're not actually spawning that much, but go into the scene view. Okay, we can turn off. Oh yeah, so now we're able to see soil spawners in the scene view. I don't know why. A second ago when I was trying to get it to show up, they didn't. But yeah, so now I want to turn off its grass terrain so we can see the actual visible meshes. And then I can look at the soil camera and I can see that it actually covers the entire terrain now. And it still looks pretty good. Let's try making the grass a little bit more dense. We do that. The grass manager. I'm pretty sure we might run out of buffer space again. Oh yeah, so that made a big difference. But that's super dense. How much? There is like a max buffer size. Let's see, if I change this to like 20,000. Okay, that's still not enough. I don't have to worry about like my computer imploding. So don't worry about that. Okay, so this actually works. Oh wow, and even rendering this much, I still am getting 600 frames a second even with OBS running, so this is way more efficient than I could have hoped for. Wow, that's nice. Okay, so anyway, yeah, this is running with 1,000,000 sprouts. Okay, so that's pretty promising, I think. But yeah, just so we can kind of see how each individual sprout looks, I think I'll change it back to just having 2 blades per unit area. And I mean, it doesn't really matter that the buffer is so big, so I guess I'll leave that. Okay, yeah, and then when grass is that big, you can't notice this weird gap, so I guess that's another, or when there's that much grass, you don't notice the gap. Okay, so now, that's really encouraging that it can run that much. So now I don't have to worry about, like I can increase the camera size and good to go. I wonder like how big that grass texture was. I should have checked. But anyway. Okay, so what else? So the grass does move with the wind. Does it? I forget if it set the bend angle. Okay, so I have the bend angle, but does it actually? Okay, it does calculate the bend angle. So that's kind of nice. Okay. So one reason I really like this system is because you can adjust all this information like on a per material basis. So we could have like a separate soil shader for like this ground, the big ground, and then also the small block. So, and that would change like the shape of the grass. Like, just making the grass wider, that actually looks a lot better. Except for this part where it's kind of hanging off the side, but... let's see. The wind noise, I think, is a little bit too sensitive. Did I do it the wrong way? I think now it's a little bit too scaled up. Something in between. And then the wind frequency, I think it was pretty good how it was. And maybe a little bit less strong. Anyway, okay, so I just wanted to try that out. Okay, so yeah, changing the alpha cut threshold doesn't really help. Okay, and the curvature doesn't change anything because right now every mesh is just two triangles. So yeah, that would be something to fix maybe. But what I want to try next is I want to change the shape of the grass by changing the texture. So in my soil text or soil shader, I already I had started adding this where based on a random value, the game would sample a texture on the soil, and then it would check to see if that value in the red component is bigger than some random value, and if it was, then it would spawn a grass there. So this way you can do like grass density a little better. Let's try that. So I'll have big soil, and then I'll just have another one for the soil cube. And so for big soil, okay, this already, okay, so it already has the gradient on it. So for the soil cube, let's put this stripe. Okay, so I don't think it worked. Because I don't see any change in the grass pattern. Although it might be a little easier to tell if I make the blades smaller again. Okay, so yeah, I'll make it look a little less pretty, but just so we can see what's going on. Okay. So maybe it did work. I think it might have actually, we just can't really see because of the main camera. Yeah, so you can definitely tell it's less dense over here. So I think that did work, actually. If I, let's try setting the grass per, or blades per unit area a little higher, and that might make it more obvious. Okay, no, that didn't help for sure. I mean, it is kind of fading out here, but it seems like it's not very... Okay, and why is this shimmering like that? Well, if it doesn't, if it doesn't happen, turn this off. I don't really because like I said before, I don't really care that much about supporting moving terrain. I just kind of had that there for testing. But if it does shimmer when we move the camera, yeah, that's not good. Oh, what's... Huh. Only some of the grass is shimmering. Oh, I bet I know why. I think it's because, yeah, this doesn't use, it uses the actual input position and not this, the snapped position. So if I just change it to be based on the grid position, like we did before, will be set. And I should use the pre-done rand function that I set up for this. I don't really think that will fix our other problem, but I will at least get rid of the shimmering. Because yeah, what was happening before was that whether or not a grass blade would spawn would change depending on the position of the camera. Okay, so if I go in the scene and then look at the grass terrain again. So this is telling us, like, the black pixels are where grass spawned, are where grass didn't spawn, and the white pixels are where grass did spawn. So we can see it is being affected. Also, yeah, this soil block is using the wrong material. I just realized. But it's just not that noticeable, but maybe it's just because I'm not using a very good testing texture. It's just a gradient. Okay, so let's try setting in that purple stripe. Okay, so that's definitely more stark. I wonder also... Okay, yeah, so this was set to be an sRGB texture, so that surely didn't help. Okay, this should be a normal map, but I don't think it's the right color blue. I'll have to fix that. Okay, so let's test this. Okay, you can already see it. Okay, so this is much more what I was thinking of. The grass does not spawn where the red in the UV is 0, or the red in the texture is 0. So now if I change the material on the soil cube to something... Okay. That didn't... Oh, okay. So the reason we can't tell, I think, is just because the soil cube, the blades are still pretty wide, so they cover up any holes. Yeah, so when we do that, you can see the hole, even though it's a little... Okay, so there you can see the hole where the texture is telling the grass not to grow. So that's pretty cool. Is there a gap? I'm not sure if there's a gap in between the block and the grass, or if it's just the weird lighting. Okay, there's definitely a gap. Why is that? Is there a gap? Okay, there is one. I wonder, is that because... Huh, why would that be happening? Because I put the actual world position here. Well, yeah, we just... Yeah, we've actually passed the world position into this function. Maybe... It's a position world space. So we add wind offset. I'm just trying to look for places where... So we multiply the tangent to world here. But that shouldn't change the y because, well, I guess it might. Maybe I think the easiest way is just gonna be to apply an offset, because I'm not sure if it's because of the shader or if it's because of like the depth texture. Oh, you know what? I think it's actually because, yeah, this texture I'm using, the grass is supposed to fade out. So it's, the alpha cutoff is cutting the bottom of the grass off. So maybe I should just use a different texture, because yeah, this isn't really made for alpha clipping, it's made for transparency. Oh, well, we could do... Oh, well, even that would work. I was going to say we could do alpha to coverage. I might already have that enabled, actually. But that's basically the same as clipping. What am I looking for? Shaders. Yeah, I have alpha to coverage on already. Okay, well, I was gonna... Let's see, maybe we can use the grass from that other project we were working on. I don't know. I don't remember how good it looked, but I think it was made for a similar system as this. I need to return to that at some point. Okay, those names are going to be confusing, but... Alright, so alpha is transparency, preserve coverage. Oh, maybe we don't want that for this because we're not... Well, I guess, no, we still are having alpha clipping. It just doesn't clip at the bottom. Okay, I definitely don't like the way this looks as well, but at least it doesn't fall off. We're getting some halos, but I'll fix that in a second. Yeah, so this stays threshed to the ground, which I guess is the most important thing. We can work on aesthetics later. Okay, so I just need to get rid of that halo, I just have to set wrap mode to clamp. Okay, So now, what's the next step? What else might we want to affect? So, with a texture. I actually asked my patrons this before, but it's been a while. Well, maybe we could do, let's see. So you could do, I guess, grass size. You could do the wind strength at a point. You could do color and like a normal direction. So yeah, we could apply a normal map basically. Let's add all that stuff, and I guess it's good to have options. Okay, so we have this main texture, and we'll have a color texture. I'll call it a tint actually. And a normal map. Yeah, and it's easy to remove this stuff because obviously adding more samples does increase the amount of work we have to do here, but I don't really think it's that big of a deal. Okay. I'm doing sample texture 2D LED. I wonder if, can I just use that load texture 2D? Let me try that before I go any further. This is like another way to sample textures, and I think it might be faster. But I'm not sure. Oh yeah, so now it's complaining. I just need to get rid of this. I don't know if it works in the fragment stage. Too many arguments. Oh right, and you don't even need a sampler for this, which is nice. Okay, so that didn't work because it's not showing the spawn points, so I'm not going to worry about it right now. There's probably a way to get that load texture 2D to work, but I don't know, it's not really important. Okay, so we have this data texture. I'll change it to control sample and then tint sample and normal. Tangent space. Okay, now what was... I think it's like there's a specific function you have to call to decode a normal map. And I think it's in the core shader library. I think it's packing, in the packing HLSL file. Let me see here. Maybe not. Oh, okay, yeah, it's right here. So they have an unpack normal, and you don't really have to do anything. You don't have to look at all these functions. We just want the unpack normal scale, I think. And you just pass the sample, and also we'll have a normal scale. Okay, so now we can perturb this normal. So yeah, most of this data will just pass into the shader. I guess we don't really even need to sample these unless grass is going to spawn. So we'll do that. And so I need to... Okay, so first we need to... Oh, hi Wonderful. That startled me, but thank you so much for coming by and raiding. Haven't talked to you in a while. How have you been doing? How are you doing today? Oh, that's all right. It's I just appreciate you coming by. Okay. So yeah, we've got the normal tangent space, and now we can create a tangent space matrix. I think that's in space transforms. They also have functions for that. Although, do I already call it? Starting to get too many files open. Oh yeah, so this create tangent to world is what I was looking for. So we can create, this is a tangent space matrix, like based not blade tangent space, but on like geometry tangent space. Making grass via the camera rather than putting it throughout the world. Oh yeah, let me show you real quick. I hope this code should still run. Cannot possibly convert. Let me see. I'll just comment this out. So yeah, I'm using a camera to project grass onto the world, and it's kind of nice because it changes based on terrain, and also you can use a texture to control where it grows. So it's I'm gonna make a tutorial about it later, and it works for a whole bunch of different setups. That's why I kind of settled on this technique. But yeah, I have this soil camera, and then if you can move it around so it can follow the player, and you can see now the camera is moving out of this range, so the grass like naturally despawns. So it kind of has LOD built in as well, which is kind of nice. Not the main camera, but what gets seen by a virtual camera. Yeah, exactly. Yeah, I don't think a screen space solution, I guess that might be possible, but yeah, this one is just a virtual camera that's looking straight down onto the terrain. You know, yeah, I'm kind of curious about doing screen space grass, but okay, so back to tangent space. What were you working on tonight? Yeah, I kind of like a grass light. That's a good way to think of it. Okay, so this will create a tangent space matrix based on the normal vector that we passed in, as well as the tangent that was passed in. And then we'll use the normal map to create a new normal and a new tangent, which will pass to this grass sprout, and that's what it will use to grow for the growth direction. Little tweaks on an interactive boon chart for Hades. Oh, that's cool. I'm gonna have to go check that out, actually. Like for a guide website or something like that. Okay, so now all I have to do is multiply. Oh wait, so this will be tangent to world. So now the new normal and the new tangent. Oh, do I have to? It's kind of confusing, but I think actually a good way to do it is if I just pass this tangent in. Oh, I don't know. Because we would multiply. Do I? Are these? Well, these vectors are the same for now, but I want like 0, 0, 1 to point straight up. I mean, I want 0, 0, 1 in tangent space to point along this perturbed normal. So I wonder if I can just pass this tangent to world in and then multiply it with I guess what I'm trying to say, I wonder if this is the same. I think it kind of is. It's a web app for now. Some kind of game integration would be nice. That would be pretty cool, like a, I don't know, an overlay or something. Does Hades have mod support? I don't know. I haven't really played it that much. Something I really need to fix, I think, but okay. So let's. I'm just gonna pass this tangent to world N and see how that works. It might just do the trick. If not, we might have to do some more math. Okay, I do need to. So Unity, without getting into too much math, like an actual tangent to world matrix has to be transposed, but Unity does some um, magic in these functions that make it work without transposing it. But since we are not using them in the later parts of the shader, we just have to transpose it ourselves. All right, so anyway, so yeah, we're just going to pass this in instead of having a separate. So wait, no, this isn't going to work because I'm not doing anything with this tangent space vector. So I need to transform this tangent space vector into world space. Okay, so what I was trying to think of, is there a way... Okay, well, let's just get this working for now. I'm confusing myself. It's too late for this much math. All right, so yeah, let's just leave this right now, and I'll transform this tangent space vector into world space. And I think that there's some way that I can like just use this vector or this matrix and then multiply it with some other stuff to get it to work all together, but so anyway, so float 3, normal world space. Okay, so transform world to tangent, transform tangent object. Okay, so tangent to world. So we take the tangent space normal, and then the tangent to world matrix. Okay. Oh yeah, so when I tried to do this before, yeah, I did run into this problem because I don't have, like, this just gives me a normal space, like a normal. It doesn't give me tangent, so I'm trying to think here. All right, let's come back to this because I'm sure there's got to be some way that I can basically use this like a normal map to like perturb an actual like a tangent space, but like I said, I don't really. That's just a lot of math, so we'll come back to that. Let's do the easy stuff first. Okay, so we have this tint, so we'll pass the tint color. As well as the control sample. I think I'm leaving my... Yeah, I was leaving this running the whole time. I can hear my computer humming. Sorry, my nose is stuffed up. Let me blow it real quick. Gosh, my allergies are bad enough. I don't need stuffy nose, or yeah, I guess my allergies are bad, so they're causing my nose to stuff, but I don't, these, my teeth thing make my voice weird enough. I don't really need my nose to help. But anyway. Alright, so what was I doing? Oh yeah, so I passed the control sample and the tent sample to this make sprout. So I guess the tent will just have to pass through in the sprout data structure. And as well as like the wind strength. I'm trying to think what else I want to add into the control sample. So I guess let's document it. So RGBA, so density, size, wind strength, and then something. And then the tent is just a tent applied to it, and then this normal map will come back to. Okay, so the wind strength I already did that in the tent, but the size we can actually just multiply here. So times control sample dot green, and then we can pass wind strength as the control sample dot blue, and the tent control sample dot, oh wait, no, this is just the tent sample, which I noticed I didn't actually add to the argument list yet. Okay, so technically we have two more floats that we could do something with, the alpha and the tent sample, as well as the alpha and the control sample, but I don't know what that would be yet. Okay, so I need to change this to the tent texture, and same with the sampler. Okay, so before I do anything else, I want to add these structure variables into the other instances of the structure, because they all have to match up. And unfortunately in the shader there's, well actually I guess we could have like an include that includes this structure, which maybe I'll do when I go and clean up all these scripts. But for now we just need to copy and paste it. So we add the wind strength and the tent. Okay, and then I can take care of the wind strength pretty easily by multiplying it here. So grass dot wind strength, and the tent will have to pass through in the vertex output. Tent. Oops. Use text chord 4. This just needs to be a float 3. Output.tent equals grass.tent. And then I could just multiply the tent with the albedo right here. I mean, I guess the tent could also have alpha. If you wanted to make your grass more transparent at a certain point. No, thank you. Oh, jeez. Okay, I need to get used to... sorry, I got a spam message in chat, and it's... the new moderator tools, or the moderator tools have changed since when I streamed before. Okay. I thought I could delete the message, but I guess you just have to ban somebody to delete a message. Alright, well it works. Anyway, what was I doing? Hint, yeah, which I multiplied with the albedo, and then with grass strength we took care of. Okay, so the only other place I need to change the structure is in the renderer feature, because that's where we specify the stride, which is how many bytes one element in the structure takes up. So that is here. So I have like a representation. I don't really need the C# representation of it, but I just do. Okay, so we're adding 4 more floats, 1 for the wind strength and 3 for the tint. And oh, I just typed the wrong number there. Okay, so let's see if there's any bugs. No. Okay, well I made a typo. Okay, so that fixed that. Now for the materials. Oh, I didn't add properties in the shaders, so let's fix that real quick. So I have the main texture and then the normal map. And then I want the tint texture and the normal map not to have their own scaling and offset, so no scale offset. I think this is the right attribute, hopefully. Oh yeah, and then I had a normal strength. So let's just add that real quick. Even though we don't support this just yet. There's got to be some way to do that. Okay, so the tint texture, let's just use this stripe. It's gonna look pretty ugly, but okay, so it doesn't work at all, which is it because no, we don't even do anything with the normal. Let's see here. Oh, this is wrong shader. I didn't change this any. Oh, maybe these dimensions, if the dimensions are 0, they're not going to spawn. So I wonder... So, okay, so green, oh yeah, these don't have any, it doesn't have any green in it, so that's kind of a problem. let's just use, I could go make something, but let's just use that and see if it works. Okay, yeah, that was the problem. Technically, it should have all green in it. I don't know. Well, let's make a new texture because I'm not sure where the files I used to make those in the first place are. So we'll just make a new one. Substance Designer will work as well as anything else. This, I'll just, yeah, empty graph. I'll call it graph. Test grass control. I'll go ahead and save it. Substances. There we go. Okay, so this, I'm just gonna call it stripe. Okay. Okay, so it already has this nice effect. We could just use this histogram scan to control the contrast and width of the gradient. And then to colorize it, well, basically, yeah, this is just a red-green, or everything is based on the channel. So they have a channel blend or channel shuffle. That's not what I wanted. Excuse me. Okay, so there's gotta be, okay, yeah, this is what I wanted. You can merge 4 into 1 output. So this will be, let's have this be, I don't want like the width or the dimensions to ever be 0, so we can do that by adjusting the levels. Okay, so yeah, now they'll be smaller at a certain point, but never a 0. Okay, so that can go into green for dimensions. Red is the density. Let's do a different pattern. This will be fine. And then, so blue is wind strength. Let's do another one. I kind of want to flip it. Oh, wait, no. It was fine because there'll be no wind strength at the bottom edge. Okay. And then alpha doesn't do anything. Actually looks kind of pretty. Let's export. Oh, I didn't make an output. So output. I'll call it the data texture. Okay, so grass control. Yeah, and we want it raw because it's not going to be a color. Okay. The other textures will do fine for tinting and everything. So it's not sRGB, and we don't need to generate bitmaps. All right. Okay, well that made a big difference right away. so let's see if we can. Unfortunately, yeah, you can't. Again, you can't really change this or view this in the scene view, which is sort of a drawback of this system. Okay, but we can see, yeah, it is being tinted. Now down here. Okay, I thought it shouldn't be getting any wind strength, but it seems like it's still doing it. So we'll have to test that. But we can see definitely there's definitely a gradient in the grass dimensions, which looks good. And then also the the density is looking fine. Although, yeah, this is kind of funny, but well, actually, this might be a problem of it not being clamped. So it's like reading density from the other side. So if we set clamp, that fixes that weird little bug. Keep on clicking. Yeah, it seems like over here there's no wind, so maybe I got it backwards. Because there's definitely wind on this side, and I meant to make it so there was going to be no wind on the side where the density was full so we could see how it looked a little better. But yeah, you can definitely see there's no wind there. Did I get it backwards? Yeah, this is black on the bottom part. Yeah, there's definitely no blue. Okay, yeah, it's using the blue from the control sample. And here it's red. I'm just checking to make sure. Yeah, all this is the same. And then here I use grass wind strength multiplied by the wind offset. Yeah, and where it's 0 is where there should be no wind strength. So I don't think this really matters, but just to make it easier to read, I'm gonna just pass pure white into the alpha. So I was like, how come it's not previewing? But it's because alpha was set to nothing. Oh, yeah, we don't want uniform color. Is there a uniform? Oh wait, actually, yeah, the uniform color, I just had to set it to grayscale mode. There we go. I don't think that was the issue, but I'm just a little, I don't know why. I mean, I'm probably just looking at different, but it's definitely blue up at the top, but no red because where there's blue and red, it should be purple. Okay, well, let's, I guess we can test it. Make sure I didn't get this backwards. If I just said, like blue to black, which means that there should be no wind strength. Oops. And that does work. Okay, I must just be visualizing the gradients differently then, because if I set it back to white, And now the wind is back. Just to make this easier, I'm gonna make the wind strength strong again. Okay, well, it definitely seems like okay, yeah, so it's definitely no wind up at the top here. Okay, then. I'll probably be looking at that. It might be interesting to make the wind strength also change based on like how tall the grass is, because some of this grass, like the shorter grass, shouldn't be affected by the wind quite so much. Okay, well, I think I'm just... Well, I mean, it works when we set them, you know, or because when we set this all to black, there's no grass. I mean, no wind, which is how we'd expect. But for some reason, when we put the gradient, it seems to be opposite. So I'm probably just visualizing it wrong. It is, it's been a long day, and it's Friday, so I don't know. I'll just rotate this. Oh, wait. No. Okay, I don't know. I was confusing myself again. Okay. So if we do this, we can bring up some more contrast, but so once again, it's like there's no grass here where I thought it would be white. Oh, maybe... Okay. Let's see. Maybe it's the... Yeah, so where... I think that the density, I have it reversed. Because where the density... So, okay, the camera is right here. And then in the game... Okay, well, this is a dense spot, which would match up. So maybe not. I was going to say maybe I have the density flipped, and instead where density is white, it's not spawning, which would be... make a little bit more sense, but... Let's look. So right now... Although, yeah, I think I do have this backwards, because now when the control sample is white, that means it will never spawn, and it should be the other way around. So yeah, it does need to be like that, I think, because yeah, if the control sample is white, that would mean it should spawn. So if it's 1, then the random will never be, will always be less than it. And then, okay, no, it should be like this, actually. So I guess there's a small chance, because when this is 0, I want it to never spawn. Okay, So I did have that backwards. Okay, so I guess that was the issue. Okay, well that was a kind of roundabout way to fix that bug, but... Okay, so now... Well, does that work? I guess so. So yes, let's see. Yeah, because now they're both white on this one side. Okay, so if I want it to go back to how it was before, I can just turn this off, and now the grass should stop on the opposite side of where the density falls off. Yeah, which it does. Okay. So yeah, that's a roundabout way to fix that, but there we go. Okay. So next, okay, so we have the grass shader and it works pretty well. Yeah, so what you do here, if you see how the grass hangs off, how I think you would fix that is you would just UV this cube and have the control texture be black close to the edge. So that way they wouldn't spawn close to the edge. That's how that's how you'd have to do it in this system. But it probably wouldn't look that good if you you know, had these sheer cliffs like this anyway. Now, I did test. If you rotate it, okay, so the grass does stay. I wanted to make sure that the grass normal does respect, like it stays perpendicular to the ground. I really would like to be able to affect the grass growth direction, because I think that this grass should actually still point like halfway between the normal and up. So maybe what we can do is we'll take that normal vector and then just take like interpolate between it based on the normal strength. Interpolate between it and the world and the actual world vector. Is that... Well, it still doesn't make it easy. So the thing I'm having issues with is this tangent vector, but I guess really, since we randomly rotate the grass anyway, does it really matter if the tangent vector here is consistent with the actual tangent vector on the geometry? I don't think so, because yeah, we just pick a random direction anyway. So we can really, yeah, we can just make a tangent vector and then pick any, or we can make a normal vector and then just pick anything that's perpendicular to it as a tangent vector. And that will work just fine. Okay, so we can get the actual normal vector this way. And then we can just make a tangent vector. So to get a perpendicular vector to the normal, you just got to take one component and negate it and flip it. So like, or swap two components and negate one of them. So it'd be float for normal world space dot y negative normal world space dot Oh, well, I don't really ever want the tangent to... Well, I guess it doesn't really matter, but... World space dot x, normal, world space dot z, and then we can just use this last bit basically controls if you're using a left-handed or right-handed axis or rule system. World space. We'll just pass that on from the input. So I think this should work because I'm pretty sure it will. I know that was very convincing. So let's make just a test normal vector here. I want to make sure that it works with just a flat normal vector, which you can, so the normal color, oh, they actually have a normal color. Yeah, node, but it's just blue set to 1, red and green set to 1/2. Looks kind of like a periwinkle. Okay, and we can export it. Implicitly convert from float 3 to float something else. Oh. Yeah, returns a float 3. Constant float 3x3 to float 4x4. Oh. Yeah, this is just a 3x3 matrix. Okay, so there we go. I think everything is going to be, well, we're not even playing it right now, but so first I need to change this normal to a normal map texture, and yeah, we don't need bitmaps. And for both of, I just realized how confusing this material name is. Let's change this to visible soil. Okay, so we can set the normal map to this blue normal, and then I'll just set the strength to 1. Oh wait, is that? Yeah, that's actually, I'm gonna get rid of this texture because I think that's the wrong color. It's not the periwinkle. Okay. Okay, so it doesn't, it looks kind of weird. Maybe, I guess, okay, I was scared that some of the grass was gonna be like underground, but why? Okay, let's turn off wind for 1. So we'll change, oh, I need to leave the direction, but I can change the strength to 0. But why is the grass like disappearing over there? Because the control texture doesn't dictate that. It's probably because of the normal map. If I set normal strength to 0, that doesn't change anything. Okay. So nothing I do affects it. I guess I should make sure that I didn't mess something up. Let's just give it back the normal and tangent input. Okay, so that looks fine. But why is it like a gradient? Because this input, it shouldn't vary over. Maybe I did the name wrong. So normal map, sampler normal map. Okay, I did update the name there. Because it looks like it's reading from some texture. That's not the normal texture, because the normal texture is constant. Oh yeah, so yeah, I'm reading from main texture and not the normal map here. Okay, so at least that fixed that bug. Doesn't seem like the normal. Okay, yeah, well the normal shouldn't do anything because it's just pointing straight up. That's what this periwinkle blue does. So it doesn't actually change the normal. So let's see. If I change, let's just make a normal that points. I don't know. Let's just put in some random color and see what happens. I mostly just want to make sure that. Okay, well that was not promising. Oh well, actually, yeah. No matter what, the blue should always be 1, I think. Well, actually, not always, but okay. The problem with this is it probably is not producing um, normalized vectors. Which I guess I could fix. So, can I? Yeah. I want to do, yeah, just red, green, blue. So a normal vector, let's just do like 0.5, 0.5. Why is it like that? Huh? Why does blue go to negative 102? Okay, I think that was just bugged. Or maybe that's like... yeah, I don't know what the deal is with that. Anyway. Okay, so 0.5 on here is actually 0. So I need to do... I think if I do 0.75, that should be a valid normal. Let's just try it out. If not, I have something else to... Okay, so at first glance, it at least isn't... Oh, well did I... Okay, I am passing in these calculated normal vectors, but it doesn't seem to actually do anything. Did I... So I named this normal scale, but usually I name it normal strength. I wonder if I... Yeah, I misnamed that. So it's always set to 0. Where is it? Here. Okay, there we go. So now, yeah, I can set this to 0 and then to 1, and it'll start to point in that specific direction. And it is, it's consistent on the geometry scale, even though we do pick a random tangent vector from it. And so that's the main point. It's an interesting effect. Whoa. Oh, it went super big again. I should probably normalize the vector after this, just to make sure that it is actually still normal, or normalized. And yeah, since this is normal, then the tangent will be normal because we just yeah, it'll still be normal because it takes the absolute value. That actually made a difference. Oh, it is because we had the strength up really high. But anyway, so I wanted to make sure that I could interpolate between the actual normal from the terrain and then the normal from the normal map, which you can. Good to see. So now, yeah, we can affect the grass growth angle by changing this normal map. And I guess, see, right now it does affect the lighting on the grass, which I guess is fine. Yeah, I've been working on trying to make a good like grass lighting shader. And in order to get it to look good, you don't really want the lighting to be, because used to I would always have the lighting point straight up from the terrain, but that doesn't really help you get a very good like specular highlight. So anyway, that's another project. But okay, so got that up. But one thing I want to do is, like I said before, when you have sloped terrain, right now the grass points outwards from the block. I should probably just make another sloped or another soil block. They can just have sloped. That's easy to see. So yeah, so right now the grass just points. Oh, I didn't want it to move up and down. So right now the grass points straight outward from the terrain, but I want it, when it's on a slope, it should kind of grow upwards because that's just how grass works. It wants to grow up towards the sun. At least I think that would look more natural. So let's what do I want to call this? Upward growth strength. And I guess we can go ahead and add a property here. Upward growth strength. Hey NTT, thanks for coming by. How are you doing tonight? It'd be cool if you could make it actually grow towards the light source, but then we'd have to care about the lights in these shaders, and that would be a lot more computation, but that would be a fun project, I think. So what I have to do here is basically before we create the tangent. Oh no, I guess it would be afterwards. So it'd be here before we what am I trying to say? Before we like do this tangent, I'll just lerp between normal world space and then a vector pointing straight up. If we want to, we could do like what they call a spherical interpolation, but I don't know. It's not super important. So normal world space equals normalize lerp normal world space float 3 1 or 0 1 0 and then the upward growth strength, and then it will take this and then it'll make the tangent vector and then just go on from there. All right, so let's get a closer look. Okay, that works pretty well. So yeah, now it will just, all the grass will grow towards the sun, no matter like what the terrain normal or your normal map is telling it to do. This can actually be a range from 0 to 1. I'll leave this like unranged, like unclamped, because sometimes you want to set the strength larger. It'll be normalized anyway, so. Seems like you missed a lot of the stream. Oh yeah, well I've been streaming for about 2.5 hours, so. But yeah, I've been working on this. I'm kind of continuing on my project from Monday, because I finally figured out how to get a camera to actually project grass. There was a lot of issues with it, but I was able to figure it out before today's stream, so I've just been working on that today. So I think I'm pretty happy with pretty much everything to do with like the grass placement and spawning. So now, one other thing I wanted to try to do was, like, again, unfortunately you can't really see the grass in this, in the scene view, but if we have the main camera and like when I have it right here, it's still drawing all the grass behind me. So what I'd like to do is do something called frustum culling, where we basically the shader won't spawn grass that's behind the camera's view. So there's a bunch of ways you can try and do it. I'm just going to do a kind of like a quote simple or naive approach, where I'm just going to take the camera's projection matrix and then project each of these points into clip space based on the main camera. And then from there, we can see if the clip space position is outside of the camera's frustum, and then just not spawn grass there. So in order to do that, I'll need to get let's see, what do I want to call it? Since this is technically growing from the soil camera, we can't just use this camera's matrix. We've got to use a separate one. So I'll just call this, I was going to call it culling camera transform, but I think I'll call it soil culling camera transform in case the other name was already picked up by Unity. So can I think, can I go ahead and, I think I can calculate this in the vertex function and then just pass it to the fragment function. And I think that will still give me correct values, but we can see how it works. I mean, we do it with normal clip space, so we'll have another vertex output. I do know that you have to normalize clip space position and the fragment function, so we'll do that. So position or culling clip space. Okay, so what I have to do, basically I just will transform the world space position using this matrix. And hopefully I'll set this up correctly. And take output, position world space. Okay, so when you work with culling space, anything that's outside the range of -1 to 1 is outside like the view of a camera. So what we can do is, yeah, even before we do this like sample, we could do culling. So we'll get float 3 culling equals input dot, oops. Okay, and so clip space is what's called homogeneous coordinates, which just means that in order to get like the actual position, you need to divide by the fourth component, and this is how graphic systems implement perspective, basically. But it's always important to do this in the vertex function because when you interpolate in a non-homogeneous space, it doesn't always work out correctly. So yeah, if still have to do a break or a branch here, which is a bit of a shame. So if culling.x is less than 0 or culling.x is greater, oh, actually less than -1, or culling.y less than -1, y is greater than 1, or culling.z is less than -1, or culling.z is greater than 1. Yeah, and for z, this is like the near and far clip plane of the camera. So if any of these are true, then we'll discard this fragment, which means that the fragment will just stop. Oh, actually, I don't really want to do that because I kind of want this texture to return black just for visualization. Let's see. Okay, well, I already wrote all this, and I might change it to do discard later. So if this is all true and this is all false, then that means we don't want to cull. Okay, so this should go up here. Okay, so I think that works right. Oh yeah, so it's saying, yeah, so this position is a vector 3, but we're trying to multiply it with a 4x4 matrix, so we need to add a 1 on the end. Okay, so yeah, nothing will work right now because, oh, well, something did work actually, I'm kind of surprised. Because I haven't set up that matrix, so it's not really going to be able to cull correctly. So I need to set this up. Can I do it? I think I only have to do it once. But I guess I'll have to do it every time something changes. I could do it in the feature, but I don't really think that matters. So I guess I'm going to need serialized field, camera, call it the view camera. Okay, so I'm going to need to reconstruct that matrix here. So I need to go from world space to view space to projection space. So float 4x4, main camera transform. Oh, before I go any further, I'm going to set global matrix. Yeah, there's probably a more efficient way to do this, but we'll optimize after making sure it works. Okay, what's it not like? Oh, it's just saying it's not been assigned yet. Okay, so like I said, I need to go from object to view and then view to clip. So I can do math multiply view camera. So objects our rotations are applied in the opposite order of multiplication. So if I want, so first is projection, which takes you from view to clip space, and then I can do it has another matrix. Oh yeah, world to camera matrix, which is world space to view space. Okay, so I think this should work. Okay. Oh right, but I didn't assign the view camera. Okay, so now I should be able to look in the scene. Oh yeah, so now it you can see that anything black is outside the frustum of the camera. And we can move it up and down and it automatically updates. Now some things, like if I get in the view of that moving platform, we might notice some things. Like obviously it only tests the base point, and so there's kind of pop in because the tip of the grass is you know, the tip of the grass is higher than the base. So in that case, I need to also test. I need to like expand the position a little bit. So I think the easiest way to do that well, I was just thinking the easiest way to do that would be to expand this by like the maximum dimensions, which would be the blade height plus the blade variance. I guess the problem is that we don't have like I don't know like which direction to expand it, because I think from this transform I can't really tell like what side of the camera I'm on. So we could just, so maybe we should just do this in the fragment function, because otherwise I'd have to pass in 4 points to the vertex or through the interpolators, which would probably be slower than just doing this multiplication. The matrix multiplication is kind of slow. There's probably, I mean, there's probably some way to do it. I think I can, let's look in the frame debugger. It might tell us like what's in the matrix, and then we can see if something matches the position. I think that the bottom row should be the position, but I'm not sure if it changes due to the projection matrix, which might happen. Frame debugger. Okay, soil culling transform. Okay, so unfortunately it doesn't look like... Yeah, I think that the projection matrix kind of gets rid of this position, because like in a lot of matrices, the position will either be on the final column or the final row, but not this time. So I mean, there might be some way to get it out of here, but I don't see it. So we have, I want to try something. I don't know. This might be like not an actual, like this might not actually work, but let's just try it. So if I have the soil culling. Oh, well, no, this won't work because I'd have to transform to view space first, and then like apply the offset, then transform to Culling's or to projection space. Would that be faster? Because I have to do 2 multiplications. Because yeah, I'll have to transform into view space, then offset by the dimensions. And then okay, maybe I'm overthinking this. I wonder, can we like, if I went back through the math to to figure out that culling transform, I could probably expand the culling, like the field of view of the camera to take in like the dimensions of a grass blade, but I don't know. I'll have to look into this, but let's just try to do like a naive approach first. So I'll make a function private. Oh no, I don't have to do private. So it'd be bool should call float 3 position and okay, so I'm gonna need another boolean. Yeah, this doesn't seem like a good way to do it, but I just want to see if it looks good. Out of, let's see, is out of bounds. Float 3 or 4 position culling space or clip space, and then we'll just take this code. Yeah, there's a better way. Excuse this boolean. There's a better way. If I wasn't lazy, I could just go back and change this to greater thans, but okay, and then oh, this was the is out of bounds. Oh, except now, yeah, now this can just be, I can just return this because it's true if it's out of bounds. Okay, so now I'll just actually I should change this to world space, and then float for position culling space or clip space. Take that. Okay, and now here we'll just return. It should call if is out of bounds position. Oh, but even now where do I? Yeah, I was gonna, because I thought I could just add the dimensions onto this, but the world space might not face the camera, so I still need to project into view space first. Yeah, so I gotta project this in the view space and then add on the dimensions. Yeah. And then I guess the other way is I could figure out the size of the dimensions in culling space. So that way I wouldn't have to transform so much. Yeah, if that was, oh yeah, that's probably what I should have done the whole time, because then I just have to transform once in a culling space, and then if I can figure out the size of a maximum blade in culling space, or I keep saying culling space, in clip space, then I just add that onto this and see if it's, so basically I'd see if culling.x is greater or is less than like 1 minus the dimensions. Okay, I'm glad I thought about that before I did this. So can I just use this matrix to do that? I think so. Should I? Okay, I could sneak that into the UV because I have 2 floats, so I could put like the size of dimensions in here. Let's see. Okay, let's make this a little bit cleaner. So the UV will just be this. And then float 2 dimensions. Culling space will be whatever. And then this will be float 4 UV and dimensions. Culling space. Okay, so I think to get this I can just like make a vector and then use the same matrix to transform it. So float 4. Do I? Oh, what do I need to keep the homogeneous component? Probably because, like I said before, it doesn't. Okay, so yeah, this won't work. Well, it will work, but I can't pack it in with the UV because yeah, it'll be a float 3. Okay, well, yeah, I'll just put it in here. I mean, it's still gonna save time. I feel like there's probably a better way to do this. Like I think I've said it a few times, but this should work. Anyway. Okay, so basically it's the same as this, but technically the dimensions are the same for every material, but so I could like use a material, that might be a good way to do it, because I could use a material, what's it called? I guess inspector script, and then it would just see that whenever you change this blade height and height variance, it could just set a matching clip space. Although maybe that wouldn't work, I don't know. Well, yeah, that probably wouldn't work because it would also change based on this culling transform. So I think this is, I mean, it's not that big of a deal. I'm kind of overthinking it. Okay, so let's see. Float to half max dimensions equals blade height plus height variance. And then blade width plus width variance. I'm going to copy and paste because I'm too tired to type all this out. Oh, except yeah, the width is actually the X component. Okay, so this is like the maximum it could be, and then we divide by 2 because to get like a radius instead of the whole dimensions. And then we can pass that here. And there's no depth, so we set the Z component to 0, and then the W component is 1. Okay, so we have that, and then now... So we have the center position. So culling.x would be like 1 minus Okay, I'll leave this should call to make this a little cleaner. Okay. Let's do float P and float 2. Oh, I guess it should be a float 3 because of the Z component. Yeah, same with that. So if P is less than D dot X or greater than D dot X, this should be negative actually. Okay. Yeah, technically I'm supposed to stop now, but since I started late and I kind of want to finish this, I'll keep going for a little bit, but hopefully I can fix this or get this implemented before I have to leave. That would be really nice. Okay, so should call, first we can get P by doing this. And then I also need to have the dimensions, clip space. Okay, float 3 or float 2 dimensions is dimensions clip space XY divided by W. Okay, and yeah, for the Z component, we'll just set it to 1. Oh gosh, float 3. And then what we return is out of bounds based on these 2 point or these 2 values. Okay. So yeah, if should call is false, then we'll calculate. We'll see if grass should spawn here. And I'm gonna leave it like this because probably later on when we're done, we'll just discard instead of having this nested if statement. Okay. Syntax error, unexpected token. Oh, yeah, that was an incomplete thought. Input. Oh yeah, we don't have these values anymore, so I just need to do that. Okay. Okay, well that's not a great sign. Let's set dimensions just to 111 and see if that works. So just make sure I didn't mess up something else. Okay, so now it's back how it was before, so let's see. Oh, also another thing. Oh, right. This is wrong because, yeah, I'm just setting it to dimensions, but this should actually be something else. Oh, yeah, so this will be a float 2 again, and then we need to construct the actual bounds vector. So bounds equals, so actually like the point is at the bottom of the Y. So it actually should like the whole dimension should be um, at the top. You should just add the dimensions to 0, whereas we need half dimensions for x. Okay, that's not really that big of a problem, but I think this needs to change to be like float 3 lower and then float 3 higher, so I'm going to have to change this again. Because, yeah, it's not symmetric. I was just not picturing it correctly. Okay, so the lower bounds is float 3, so it's negative dimensions, clip space, and 0. But it's also got to be sent. So yeah, we add this to like the bounds of actual clip space. So okay, so it's -1 plus the dimensions. And then this is just -1 because bottom is just right at the position, and then also -1 for z. Okay, I think I'm doing this correctly. Okay, so it's the same for this except not negative. And then for the positive z, we actually add both our dimensions times 2 because we add the entire height to the top, and then +1. Okay. Oh, it's saying redefinition. Okay, I'll just take off the clip space then. Oh, right, and this should be dimensions dot x dot x dot y. Okay, that's a good sign. That's not right though. Maybe it's... Huh. Well, anyway, I think I'm on the right track, but I think I've got the math a little wrong. I'll do a little bit more research on this, and probably, well, I might have work on this a little during the weekend, but we'll probably do more on this project on Monday because I need to finish this. I need to start getting tutorials out about this by the end of the month because I have another project I have to do in July, so I have like 2 weeks left, so wish me luck. But we'll do... So yeah, I'll probably work on this some more later. But yeah, for now I've got to get going. It's already stayed almost 15 minutes later than normal, so yeah, thanks everybody for coming by and watching. I really appreciate it. Sorry for the kind of rocky start to the beginning of the stream. I don't know what was up with my internet, but it does look like it's gotten a little better, so that's good. But yeah, thanks everybody for coming by. I'll be back Monday at 9 US Eastern time because I stream Monday, Wednesday, Friday at that time. And also, of course, my YouTube video will go live at noon Eastern time on Wednesday. It's going to be about drawing 2D rectangle SDFs, which is turned out to be pretty fun. Yeah, so everybody, I hope you have a great weekend, and I'll see you Monday. Bye-bye.